Hello, let's solve pips. We've got 2 by Ian and 1 by Rodolfo today. We'll start it off with the easy puzzle. Let's place some dominoes. So we need double zero. We've only got one way to do that. We need a 4 pointing into greater than 7, which I think basically needs to be this 4, 5 for that to work, which means this would be that, which means this goes there and this goes here. There we go. That was the easy puzzle. Let's try the medium. Okay, we need 4 of something. So we need a double right here, which could be only 2s, it looks like. Then we need 2 connecting to a 4, 5, or 6 to make something that can reach 10. It's only one possibility there. So that's there, which means we need a 6 connecting to something that a 2 also, well, we need a 6 and a 2 connecting to things that add to greater than 3, which could easily be this 5. If it were this 0, it would be impossible because, wait, why did I say that? Oh, right. If it were this 6, 0, this would not be possible because then we wouldn't have anything, our other 2, we only have 1, 2 left actually, so that can just go in there. So we need greater than 3. So this 6 needs to be anything greater than 0, which in this case is a 5. All right. So these 4s cannot be completed in single dominoes, which means they need to overlap with one another. So that's either this 1, 0 or this 4, 3. And what that means is that one of the 4s is 3, 1, because those 2 dominoes involve, that's one of the ways to make a 4. So I think what that means is we put the 3, I guess we could go either way. Yeah, wait, sorry. No, it goes this way. Sorry, it goes this way because then we put 1, 0 here. We can put the 6 up here, and we put a 0 here to not break the 4. And there we go. Okay, great. Let's move on to hard and hope this isn't as much of a disaster as these have been for me recently. We're spelling owl in the grid. Very good. Okay, so we need 3 of something up here. It might connect to the 4. What 4s do we have? 4, 0, 4, 1, 4, 2. We do have a double 0. That's it, actually. So if the 4 points to the left, I think it needs to be 4, 0, and then we'd have a double 0 here, which also means we need 5 in a single domino here, which we can achieve. It would have to be this. No, it could also be 5, 0. And then we'd need a double over there, which actually we don't seem to have. So this is not how it works. It's not how it works, which means we need a double something in this equivalence region that goes up at the top. And is this our only double anything? I think it is. So that does need to go there, which isn't enormously helpful because we have plenty of other zeros that can come off of it. But it's something. We also have a 0 coming up out of the bottom right tine of the angle of the W. Oh, we need 3 in a single domino as well, which could be 3, 0 or 2, 1. And greater than 4 connecting to something that won't break 4. Which is slightly, it's not that difficult, but it's a little bit difficult. It could be this 5, 3, which would then have to connect to 1 and then something less than 2. So 1 connected to a 1 or 0, which could be this. I'm not saying this is right. I'm just sort of looking at these. But the greater than 4 could also be, 5, 0, in which case we could have a 4 in here. So there's various ways to do this. Or it could be the 6, 4, which would be a 0 connected to something less than 2. All of those are possible. All of those. Greater than 4, so a 5 or 6 connected to something we have 2 of. And that's maybe a little, actually, this looks a little bit more tricky, because then whatever the 2 of needs to come off of a 2. So for instance, if it were this, it wouldn't work, because we don't have a 6, 0. So yeah, maybe this is the way to look. What about if we turn it upside down? Do we have a 5, 0? We do have a 5, 0. So this could work if it went this way. 5, 3 does not work because we don't have a 0. Oh, no, we do have a 0, 3. Sorry, that would work as well. Okay, that's too bad. Right. This 5, 0 wouldn't work because we'd need another double 0, which we've already used. Okay, so there are, a couple of possibilities there. Oh, here's another greater than 4 equal to an equals. Oh, that's interesting. And this one, it's the same situation, except that instead of connecting to a 0, it connects to greater than 0. Interesting. That's much easier to achieve, I think. It is easier to achieve. For the most part. Okay, so how do we do this? This stuff does feel all connected. It feels all interconnected, but I'm not quite sure how to see far enough ahead. What about coming off of this 0? 0, 1, 0, 3, 0, 4, or 0, 5. All of those are theoretically possible. 0, 5, I guess, would be the hardest, but still not very difficult. You know, we could then put a 4, 1 in here and a 1, 0 here, and that would work. Right. What are we doing here? What about coming off of this 4? Are these things limited at all? If this were 2, 4, 2, we could have 4, 1. We would then need 4, 0, which we have. That's possible. 4, no, well, yeah, 4, 6. Oh, that's funny. Once again, we would have 6, 5, then we'd need another 0. We'd need another 0. Oh, wait, no, this doesn't work. This doesn't work because we would need another double 0. We don't have that. So that's not 4, 6. 4, 1. 1 connecting to something that doesn't break 5. That looks not difficult to achieve. Well, no, yeah, we could do this, for instance. 1, 2, and then 3, 0. That works. Yeah, this isn't. Then another 0 here. Well, maybe this one's a little bit tougher. Yeah, this one's actually not possible, I don't think. I don't think there's any way to make this work with what we have. No, I don't think there is. This is not possible. I mean, still haven't narrowed it down enormously. How many zeros are we going to need? 2 more at least. We have 4 of them. But I don't see other places where they're strictly necessary. So maybe the question is, where could they go? I don't know, one of them could go in here easily. Oh, it's another tough day for me on the hard pips. I do not know what I'm doing clearly. What about things greater than 4? We have 5 of those. Maybe those are difficult to put in places because they, you know, one of them could go in this. Oh, wait. Yeah. One of them could go in this 5 in theory, if it were a 5 and it were paired with a 0. Is that actually possible or not? I think it is. Because, yeah, we looked at that before. We could do this. Then we need a 0 pointing up, which is not very difficult. It could be something like this. So we could put up to 1 high digit there, but we could also put them in there or down here. One of them has to go here. One of them has to go here. Oh, right. Okay. So we need, oh no, and another one down here. Sorry, this is what I missed. So 1, 2, 3. We have 3 greater than 4s accounted for. And we have 5 in total. So we only have 2 left. We only have 2 left. So maybe the point is, if one does go in this 5, maybe it's actually difficult to put it elsewhere. Oh, it could go in the greater than 0 is where it could go. Or they could go in one of these equivalence regions. It kind of feels like it's what it's going to be, but I'm not certain about that. Right. 2 of them are connected to each other. Yeah, where could this 5, 6 go? That's worth thinking about, perhaps. I mean, it could go over here. Yeah, we have kind of looked at this. It could go over here. Actually, Are those the only, are those the only places this could go? I don't think it could go anywhere up here. Because then we need double zero here. Okay, so maybe the point is it does actually have to cross into one of these equivalence regions, which would be, that would be all of our 5s and 6s, wouldn't it? I think it would be, which I think means we can't use one in that 5. Is that enormously helpful for any reason? So this would then be 5. If this were this way, this would be 5, 0, which is fine. Then we couldn't put high digits up here over that little in the L, which that in of itself is fine as well. What if this were the other way around? I think this is equally, oh no, this isn't fine. No, this doesn't work. This doesn't work. So this could go this way. What about down here? Also not difficult, I think. If it went here, yeah, this is pretty easy because we could put 5, 3 there. If it were the other way around, yeah, we could put 6, 4 there, and that's fine as well. And we still seem to have plenty of 4s. Okay, so I mean, I made one small deduction, but it doesn't seem to be hugely helpful. I think what we've learned is one of our two-sized equivalence regions in the W or the L consists of 2 5s or 2 6s. And this one up here does not. But that doesn't feel like doesn't feel like it's that big a deal. I think we already knew it couldn't go up there, actually. You know, that already wasn't possible up top. So, right. Using our zeros feels dangerous. If that's 4, 0, this would also need to be 0, and then it would need to connect to something that doesn't break 5, which will be a 1 or a 3. Can't be the 1, because we would need a 4, 0 down here. So it would be the 3. Oops. Then this would be 2, 0. Oh, that's not possible either. Is that true? Could this never be 4, 0 up there? Did I learn that and forget about it? I don't think it's possible for that to be the case. No. Yeah, it couldn't be that either. Oh, okay. So maybe that can never be 4, 0. So it's 4, 1 or 4, 2. This couldn't be 1, 0, because then we'd need 5s. No, it could be. We could have 5, 0 over there. That's possible. 1, 2, then this could be 3, 0, which we also have. So 4, 1 is fine in 2 different ways. What about 4, 2? This would then be, yeah, this works as well. It's also fine. Ugh, okay. So 4, 1 or 4, 2 up there. Oh, I don't know what I'm doing. Sorry. I can't believe I keep being this inept at these hard puzzles recently. So the 0, 4 could go up there, depending on how that falls. Or it could be here or even here. Yeah, because this could be like this. I wonder if this 3 needing to be 0, 3 or 1, 2 is limiting the stuff up at the top in the O. I wonder if that's the case. Like if this is 4, 1, problem is this could still be, we could still not worry about that by doing this. And then we still have 2 possibilities for that 3 over there. Is it trickier if we do this? This would then have to be 3, 1. This would have to be 4, 0. I mean, it's all still fine. What am I missing that's a big problem and a big constraint? I don't know. I do not know. I guess in this specific situation, which is it's kind of totally arbitrary, this 0 couldn't be this 0, 1, because then we don't have a 1 connected to greater than 4. So this would have to be 0, 5. Then we'd need 5 connecting to something greater than 4, which would have to be 6. This is all just conjecture, though, which it's not an interesting solution here. So this 4 would have to be a 5 or a 6. So it could be that, and then it would be this 1, 0, or it would be this 6, and that would be 0, 1. Either way, the 1, 0 is 0, 1 is being used. Over here, this greater than 4 couldn't be a 3 because we don't have another 3. This would have to be the 6, 4. This would have to be 4, 1. Less than 2. Yeah, this works, I guess. No, does it? No, it doesn't. No, it does. Yeah, I mean, not a good solve. What did I miss there to move forward? Again, as yesterday and often recently, I'm happy with the deductions I did make, but I'm not happy that I stopped finding good deductions after that point. So people are usually pretty good at explaining in the comments what I've missed. Hopefully that happens again today. Anyway, those were the pips. Back tomorrow. Bye for now.